A very warm welcome to all my dear students of Class 6 St. Joseph's Academy. In this video, we are going to discuss Chapter 5, Light of Physics. In this video, we will learn about a ray of light and a beam of light, rectilinear propagation of light, pinhole camera, shadows, and eclipse. A ray and a beam of light. The light given out by a point source spreads in all directions, moving in a straight lines. The light traveling in one direction in a straight line is called a ray of light. A group of rays given out from a source is called a beam of light. A beam of light can be of three kinds: a parallel beam, a divergent beam, and a convergent beam. Rectilinear propagation of light. The motion of light in a straight line path is called rectilinear propagation of light. In the given diagram, you can see the light from the candle reaches the eyes of the person if the straw is straight. If the straw is slightly bent, then the light gets blocked and the person is not able to see the light of the candle, which proves that the light can travel only in a straight line. This property is known as rectilinear propagation of light. Applications of rectilinear propagation of light. Pinhole camera. The pinhole camera is a simple application of rectilinear propagation of light. The given diagram shows a pinhole camera. In a pinhole camera, we take a cardboard box and on one side of the cardboard box we make a small hole, and on the other side we place a screen or a tracing paper to obtain the image. Here we can see that when a lighted candle is placed in front of a pinhole camera, the light travels in a straight line from the candle and its image is obtained on the screen inside the pinhole camera. Characteristics of image formed by the pinhole camera. It is real, that is, it is formed on the screen. It is inverted or upside down. It is generally smaller in size than the object. Shadow. If an opaque object is placed in front of a point source of light, it obstructs the passage of light and produces a dark patch on a screen placed behind the object. This dark patch is called shadow of the opaque object. A shadow can have two portions, umbra and penumbra. Umbra. It is a portion of shadow where no light reaches from the source of light. Due to the opaque object, it is completely dark. Penumbra. It is the portion of shadow where a part of light from the source of light reaches the shadow even in the presence of opaque object. It is not completely dark, it is dim. The given diagram shows the formation of shadow. When a brown ball, which is an opaque object, is placed in front of the light source, then the light coming from the source gets blocked by the opaque object and a dark patch is formed, which is known as shadow. The completely dark portion where no light reaches is known as umbra, and the partially dim portion where some part of light reaches the place even in the presence of opaque object is known as penumbra. Eclipses. Eclipses are examples of formation of shadows in nature. There are two kinds of eclipses: lunar eclipse and solar eclipse. Lunar eclipse. On a certain full moon night, when the earth comes in between the sun and the moon, the earth casts a shadow on the moon. The part of the moon which lies within the umbra of the earth will not be visible from the earth, thus lunar eclipse takes place. The given figure shows the formation of a lunar eclipse which happens when the earth, sun and moon comes in one line and the earth is in between the sun and the moon. So, the earth acts as an opaque object and casts its shadow over the moon. This is known as lunar eclipse. Solar eclipse. On a certain new moon's day, when the moon comes in between the sun and the earth, the moon casts its shadow on the earth. This is called solar eclipse. From the given figure, we can see that when the moon has come in between the sun and earth, it blocks the sunlight coming from the sun and casts its shadow over the earth. This is known as solar eclipse. Total solar eclipse. During a total solar eclipse, the moon completely obscures the sun from Earth's view. This type of eclipse occurs mostly in winter as the moon requires close proximity to completely hide the sun from view. From the given diagram, we can see the complete solar eclipse or the total solar eclipse. To see an eclipse, no eclipse should be seen with the naked eye because direct rays from the sun may harm the eyes. To see an eclipse, a cardboard with a pinhole must be placed before a wall or screen and the image of eclipse formed on the wall or screen must be seen through the hole. Thank you and have a very nice day.